There we go. It started. This is Tuesday, 10/29/13. Geometry first period at the Washington State School for the Blind. I'm J.J. Isaacson, instructor. Stormy, Bryant, Jessica, Angelica, Abby, and Rahel are all present today. And here we go with the review. We are on page 134 in print down at the bottom, and then 134G in Braille. Is everybody ready?
Yeah.
What does this first section say? Let's see. It says, name and identify parts of angles. So this was where we first started in this entire chapter. And they have a graphic you need to look at. And it looks like we have our... Yeah. Did you find the points, Abby? X, Y, Z.
Examine your zipper.
Examine your zipper, yeah. X, Y, Z. They have buttons for the points, don't they?
Mm-hmm.
They have a button at X, a point at X, and a point at Z. And then they've also put a number 1 in the towards the interior vertex of the angle, and then they've also put a point inside of the angle A.
Why do they have a point inside? Like
because they're probably going to remind us about all the stuff that's going on here. Why do they have a point on the interior of the angle? What kind of point is that? Is it interior or exterior? Interior. That's why. And then what would you call from Y to X? What is that?
Exterior.
Array.
Oh,
Yes. Array. And also, and then what do you call it in terms of the angle? It's array, but what is it in terms of the angle? I'm sorry, what is YX, ray, YX in terms of this angle? Starts with an S. Side. That's the side of your angle, right? What's the other side of your angle? YZ. Good.
Y or YZ?
YZ. Why would you call it?
Array.
Yes, Abby, because it's array. Excellent. All right. And then we have to name this angle, and we can name it in 4 different ways. So, angle 1, Jessica's got. Stormy, what do you have?
XYZ.
XYZ.
ZYX.
ZYX. And Bryant, what's the final way we could name this angle?
Y.
Why? Yeah. Why? Go to detention. I set Brian up, didn't I?
He did not see that coming. He did not see that coming.
He did not see it coming. Are you smiling, Bryant? Bryant disclosed to us about a month or so ago when we got on some conversation about getting in trouble in school that he got in trouble in 1st grade. He got put in timeout or sent to detention or whatever. And we were like, well, what happened? And he said, I was asking why too much. But Bryant is very, very smooth in how he delivers his lines, and so he just went, I was asking why too much. Like he just delivered it, and we all laughed and laughed and laughed. And he's back in Idaho going, these girls are crazy.
You're with the crazy girl group
right
now.
Okay, and point A is in the interior, so you got all that. That was a pretty decent graphic, isn't it?
Yeah.
Yeah.
But they name 4 ways, but if 5 ways or something?
No, there's 4 ways. So XYZ is 1, ZYX is 2,
1.
angle 1 is 3, and angle Y is 4.
And what about A?
That's just reminding you that you can have interior and exterior points, correct? So A is an interior point, X and Y are at points on the angle. I wish they had an exterior point. That would have helped.
Right on the point though.
Yeah.
Yeah.
Oh, well, whatever.
All right, so turn the page, and you have to practice now on H134, number 11. It says name each angle in 4 ways, then identify its vertex and sides. So you have array extending from 12 o'clock down to about 8 o'clock. And it's going through a point, and that point is labeled F. And then it's at G, so you have that ray, G, F, and then you have from G going through about 3 o'clock you go through point H. You have another ray. And then there's a label on the interior of the angle of 5. All right, so Angelica, start us out with naming one way you can name the angle.
FGH.
What would you like to do?
FGH.
FGH, angle FGH. Abby, how else can we name the angle?
HGF.
HGF. Jessica, how else can we name the angle?
Angle.
Angle G. Stormy, what's the last way we can name the angle?
Angle 5.
And Bryant, what is the vertex?
G.
Good. And Angelica, what's one of the sides?
FG. Wait. GF.
GF, ray GF.
Ray
Make
GF,
sure
yeah.
you say it's a ray. Good.
Yeah,
And then Stormy, what's the other side?
GH.
Ray GH. Good. Excellent. All right, turn your Braille page to number 12. You have another tactile. If you start in the top left-hand corner, there's an arrowhead, and then you go almost immediately right. You go through a point S, and then you get to the vertex T, and then you go down from T through about 8 o'clock, 7 to 8 o'clock, and you get through point U. Good. And then there's an arrowhead. In the midst of your angle, close to the vertex, is the number 4. All right, 4 different ways. Jessica, first way.
Angle 4.
Angle 4. All right, Bryant, name another way.
T.
Angle T. Good. Angelica.
STU.
Abby.
USG.
U. What?
UTS.
UTS. Why did you correct yourself?
Because that way the vortex and it go down.
Correct. The vertex point is always in the middle, right?
Yeah.
That way, if you're ever reading a story problem and it says angle XYZ, you immediately know what the vertex is. What is the vertex on angle XYZ without even having a drawing?
XYZ.
Yeah, what's the vertex?
Z.
Z. No, XYZ. Vertex.
Oh, Y.
Y. Yeah. Because that's the rule, right? What's the vertex on LMN? M. What's the vertex on AKB?
K.
K. All right, good. So it's always the middle point. That's the rule. That's the code, right? All right.
What?
Bring us on home, Stormy, by naming the vertex and both sides.
Which one were you doing?
We're still doing the same one. The vertex.
T.
T.
And one side is TS.
Good.
And the other is TU.
Excellent. All right, turn the page, Braillers. Angelica, we're in the very bottom right-hand corner. You got it?
Yep.
Angelica said stew. That's the word I used to say instead of stupid.
Stew. Your stew.
I had a text. I had a phone and I would text people. My signature was stew.
It looks like it could be, but how do we know for sure something's a right angle, Abby?
Because they go boom.
No, according to our code. What would we have to know? What would we have to absolutely know it's a right angle?
Square in the center of
a
it.
little button, like square button.
There's a little square button and close to it. This is not a right angle. It looks like it might be, but they could tell us it's a right angle.
Up to, I think.
They could say the rays are perpendicular to each other, and then you would know, right?
Too cute.
All right, the very top of your tactile, so at the 12 o'clock position, you have a point P. From point P, if you go to the left through about 8 o'clock, you go through point N. You see that? Yeah.
Yep.
All right, back to P. From P, go through to about 4 o'clock through point O. All right, so you got a ray there, PO. Go back to P and go immediately down through 6 o'clock, and there's no point on that particular ray. They just have a ray. But then to the left of the ray, they're labeling close to the interior vertex at 2, and to the right, 3. Okay? So your task in number 13 is to name all angles having P as their vertex. Name all angles having P as their vertex. So it's a little trickery because they did not put a point on that middle ray.
But we're not going.
We don't have to use, do we? The little
So-
metal thing?
You do, because isn't that...
Make it a letter?
No, but because they put numbers in there, we can name them by their numbers.
Angle 2 and
Angle 2 and angle 3, and then what's the third angle that you see?
Angle.
Oop, careful.
Oh, like angle Z. Wait. Angle OPN.
OPN, the big one, right? 2 and 3. What are 2 and 3? What kind of angles are they sitting there next to each? Adjacent. Good. So 2 and 3 combine to make the big angle NPO. We cannot say angle P, can we?
No.
No.
If they divide, if they share it.
Yeah, once we share array, then, oops, now we can't use... So the 3 angles we would name are NPO, or you could name OPN, and then angle 2 and angle 3. They did that on purpose. They didn't put a point out on that ray because they wanted you to just name them by their
They
numbers.
confused me.
All right? Is Q... Oh, there. Oh, look at that. I missed that on my tactile also. Feel up towards the top right of your tactile at about the 1 o'clock position. There's a point Q.
Oh, there is it.
Yeah.
Oh, you know this?
Yeah, that one.
It's here.
It's not.
Wait.
Did you find it? Did you find it, Stormy?
Yeah, way up there.
I'm not seeing it.
Okay, so from P,
Up above the angle.
yeah, up above the
Line
angle
right.
on the right, till about 1 or 2 o'clock from P. Feel around and you're gonna find a dot and a Q.
It's not on the angle itself.
No, it's not. It's hanging out where they want to know, is Q in the interior, exterior, or on?
Exterior.
Exterior. Did you find it, Bryant?
Yeah, I
Okay.
did.
Yeah, so that's what they were asking.
Way
Q is way exterior. Yeah.
That's kind
Alright.
of, though, 14 was kind of an easy question.
Yeah, I know.
Yeah.
Yeah.
Once you found it.
But that's nice. Sometimes it's nice to warm your brain up with easy ones, huh?
Yeah.
All right, turn the Braille page. And this just reminds you what protractors look like, right? It's a pretty decent tactile of a protractor.
I'm not familiar.
I'm not going to trace this. What's that?
I never practiced with protractors.
Oh, you haven't?
No.
Oh, we probably should do that.
No, sir.
No, we shouldn't.
Because she did it before algebra and geometry.
Okay.
That's why she has idea. I don't.
Okay. How about when you come after school next week
Next one.
for algebra review?
And then we do protractors.
We'll do a protractor for the first 10, 15
Okay,
minutes.
cool,
It's
cool,
not
that
hard.
works.
Okay.
Totally works.
I'm not gonna have you measure things on your test. I'm just gonna have you identify the kinds of angles. Measuring with protractors is good, but
So
then
is
it's
this
kind of one of those things
protractor?
that you don't really do much after you do it in class.
Is this protractor?
That is a protractor. Yeah. Have you ever seen a real one?
No.
I have.
I have to.
Yeah.
Hold on, Stormy and Brian. I'm getting to have you a real protractor.
Great.
Great.
Abby's excited about that.
Yeah, because I want to learn so bad.
Yeah,
Oh, yeah.
I've seen one.
Have you seen protractors, Brian? Yeah.
Yeah.
Imagine
Brian.
Ramona's probably taught you these.
Yeah.
The line.
That way. Like that.
So you go straight
Yeah,
up,
they're almost the same, huh?
you create
Yeah.
Can I have a metal one?
You want a metal one also? It's Braille.
anything over here.
So anyway,
Never had a real one
this,
before.
what do protractors do if you like to use them or you want to use them? They measure angles. That's right.
There's supplementary for
This
you.
isn't a cute angle.
Yeah.
You can create different angles with this. That's a good thing. So Jessica just made it really tight and said it's an acute angle. So how many degrees would it have to be if it's an acute angle?
How do
Less
you
than
read
90.
it?
Less
Less
than
than
90.
90 and more than
Uh-huh.
a 0, right?
Oh, yeah, it does.
Yeah.
Is this the right
What
angle?
if, what is it? Almost. You got to push it all the way to 90. So find your 90 marker.
And you're 90.
That's a right angle. It should be.
There.
Let's see.
More like an L.
Yeah, you're narrow.
Okay,
Say the 5 and
yeah,
a 6.
that's the three dots.
You have a
What do you need that stand for?
All right.
I've never seen
All right. Okay. Then we probably should work a little bit with these.
I didn't like Braille.
All
I didn't
right.
like the print one.
So 90 degrees is what kind of angle?
right.
And then if we go to the left of 90 degrees,
I don't know how you can't.
how many?
What is the 90 there?
I know 9D metal, but if you meet a move, how do you know?
I know it. We gotta figure this out. We got a 1,
Does this thing go by 30s or
we
something?
got a 1 dot, 2 dots, and 3 dots. 1 dots, 2 dots, and 3 dots.
1, 2, 3.
I made a 180.
No, 1, 2, 1.
I made a
We're gonna have to figure it out.
What?
Okay.
This is not good braille.
So, what do we get when we go past 90 degrees? What kind of angles?
Obtuse.
Obtuse. Good job. Obtuse.
Little
All right. So that's what you need to know from this particular section, is knowing how to label your angles. That's what you're going to be asked, is what is the measure of your angles, or even not measures, but what are they? Classify them: acute, right, or obtuse.
What kind of angle is this?
What kind of angle is that? Well, it depends on your orientation.
It's not quite a straight angle.
It's not quite a straight angle, so it could either be a really tiny, tiny acute angle or a really big obtuse angle.
I think it's a really big
Okay. All right. Turn your braille page. Now, I'm not going to have you measure angles. I don't find that a real life application anymore. But you do need to be able to classify them. So let's take a look at this particular tactile and find all the angles and classify them.
Are we still doing the...
Nope. 135A. All right, start down on the lower left-hand side and find point L. Okay? And go immediately right through the 3 o'clock position. You're going to go through a vertex point at Q, and then all the way over to point P.
What is
All right.
the P in the world?
Let's put our brains on from all that we've learned
There's more.
from L through Q through P. What is that?
There's more.
I know there's more, sweetie.
Linear.
I'm asking questions. There we go. It's a line, isn't it?
Yeah,
It's
that
linear. And what kind of angle is that from L to P?
180.
180. Good, good. It's a straight angle. Excellent. Okay. It does. It makes sound effects too. All right. Go back to Q. So Q is our vertex, correct?
Yeah.
All right. From Q, go through about the 10 o'clock, between 9 and 10 o'clock, about the 10 o'clock position, through another point, M. All right, so we have a ray QM. So we've created an angle so far, haven't we? How would we name that angle?
MQN.
MQL?
L.
Oops, go back to L. I'm looking at the first one. We haven't gotten to N yet. Yeah, so MQL or LQM. What kind of angle is that?
Acute.
A cute little angle, isn't it? Is that a cute little angle? All right, go back to Q. Go up to N. All right, N.
It's so cute.
It's still... Now, if you go from M through Q to N, so angle MQN, that's the one, Stormy, you were naming, or NQM, what kind of angle is that? Acute angle. Good job.
There are no right angles.
There are no right angles. If they would have put a box, I wish they would have put a box, because NQL looks like it could be right, doesn't it? But they did not tell us that NQ is perpendicular to LP, so we can't assume it. They have to give us that, or they have to put a box.
There's no obtuse angles.
Yes, there is.
Where? Oh.
Oh,
Wait a minute.
Oh, go back to Q and go up through about the 2 o'clock position through point what? Oh, good. All right. Now, that little angle NQO, that's another acute one. But go back to M. Now go MQO. What kind of angle is that? MQO. Ooh, what kind of angle is that? Obtuse. It's obtuse. What kind of angle is... Yeah,
Another.
Angelica, right. LQO. That's another big obtuse angle, isn't it?
No.
All right. Go back to Q. And we go from O to Q to P. What kind of angle is that? Another acute angle. Good. Now, if they had a right angle indicator, NQP or NQL would have been right angles, but we don't know that. They messed up there. I would have suggested them putting a right angle indicator on there.
I don't know if it's braille or not, hey?
It's not Braille because it's not in your text either. I'm just thinking in terms of teaching that it would have been nice to have a little right angle indicator.
Yeah.
All right. Yes, dear.
So that 45, 45, 45.
No. We don't know if it's 45, 45, 45, 45. We don't know the measurements. They haven't given us any of those. Don't assume those.
Oh.
I would roughly say LQM is about 30 and MQN is about 60 and MQO is about 40 and OP. But I could put my protractor on there and figure out, but we're not going to. But don't assume that if it's just split up into 4 that it would be 45. We have to have some givens in order to find that. Okay?
Some proof.
Cool.
All right, but we do have. Do we have adjacent angles going on here? Yeah, all over the place, don't we? Do we have linear pairs?
Yeah.
Several of them.
Okay, good. Down.
Mm-hmm. LQM is a linear pair with MQP, right? Yeah. We're going to get to that here in a minute. In 3-4, we talk about adjacent and linear pairs, but we can still think about it in this section because you already learned it. Right? Lots of rays going on. Common vertex, common rays, right? All right, turn the page. Turn the page twice. Okay. All right, 135C. These tactiles are pretty good today. Sometimes they're not, Rahel. Sometimes they're very entertaining.
Like this last figure.
Sometimes they get crazy.
This last figure is crazy.
It is. Hopefully they did a good job of it. Let's see. I'm looking ahead. Looking ahead. Oh, it's not bad. All right. Okay, so our tactile middle of the page for 3-4 is about identifying adjacent angles and linear pairs. No. Finding bisectors. This is 3-3. Sorry, 3-3, finding bisectors. So you turn your brains on. You already know what a bisector is.
Where are we at?
A bisector. We're on C130.
So find your vertex, kind of down bottom left. What's your vertex point? K. All right, from K, go up to almost 12 o'clock. It's past 11 o'clock. Through point, what? J. Good. All right, and it has an arrowhead. Then go back to your vertex K and go through an interior point at about 1 o'clock. At L, good. And that's an interior point. So we've created.
How is that
a ray
interior
on
when
the-
it's on the line?
Well, I mean, it's on the interior of JKM.
Yeah.
Okay, angle JKM, it's on the interior, right? It's on the angle of JKL and LKM, but it's in the interior of JKM. Does that make sense, Angelica?
Not
Okay.
really, but
Okay. All
I
right.
think I follow you.
So JKM, L would be an interior point. Okay?
What?
This angle here, JKM, the big angle,
Ah.
L would be considered an interior point.
Okay.
On JKL, L's considered on the angle.
Kind
Okay?
of confusing.
It is, but you have to look at it as different angles, right?
Okay.
And its relationship with the different angles.
Right.
Okay, good.
Angle.
All right,
Right. Angle.
right angle. All right, go
Sorry.
back to K and through about, not kind of in between 2 o'clock and 3 o'clock. M, good. Point M. All right, and then they've labeled down close to our vertex in the interior, they labeled the angle on the left, angle 1, and the angle on the right, angle 2.
How did they bisect? Because they have adjacent, but I don't get it. You
Mhm.
bisect.
Well, it says find the measure of angle 2 if the measure of angle JKM is 74. So they're not doing a bisector yet. This is not a bisector.
Not yet.
And it doesn't even look like it, does it?
No.
Okay. So if we have to find the measure of angle 2 if the measure of angle 1 is 28. Or no. Yeah. If the measure of angle 1 is 28 and the whole entire angle JKM is 74, what do we have to do to find the measure of angle 2?
Subtract.
Subtract. We're using what postulate to do that?
Subtract.
What postulate? What theorem? What postulate?
Subtraction.
Well, almost. Angle addition postulate.
Angle
Remember?
subtraction.
AA, the angle addition postulate.
Oh.
Because that says that two adjacent angles, you can add them together to get one big angle, right?
Yeah.
So if you have the measurement of your big angle and one of the angle, you can use your subtraction property of equality to find the answer. So you're using two different properties here. You're using your angle addition and your subtraction equality, right? So we have 74 minus 28, and we end up with 46, okay?
Mm-hmm.
So that's your example. Let's turn to the next graphic on page D135. And let's start up at the top right of your graphic at point, what do we got? Point F? Yeah?
Mm-hmm.
Yeah.
Okay.
Yeah.
So follow point F down along that ray to your vertex point. You find it, Abby?
Mhm.
E.
E.
Okay. From E, go down through about 7 o'clock through point I. 135D.
Oh,
Got it? Okay. So we went from F to E, a vertex point, and then from E to I. Now go back to E and go immediately left through the 9 o'clock position through point, what, H?
Yeah.
Good. And go back to E and go through about the 10 o'clock position through point G. Okay, we got all our rays now. Lots of angles going on. Now they labeled in the interior of several of our angles. If we at FEG, so the top point, FEG, that first angle, they labeled it angle 3. GEH, the second angle, GEH, they labeled it 4. And HEI, they labeled 5. Did you find all those?
Yep.
So IEH or HEI is 5. HEG or GEH is 4. And GEF or FEG is 3. Right? So we got our way around the tactile, right? We found everything. There's no exterior points. Okay. It says number 19. It's at the bottom of your page. It says find the measure of angle FEH if the measure of angle 3 is 52 degrees and the measure of angle 4 is 31 degrees. So when you go find FEH, so F is up at the top, back to your vertex, and then immediately through 9 o'clock, that's FEH. It's made up of 3 and 4, isn't it?
So 52.
So 3 was 52 and 4 was 31. What is the measure of FEH?
Wouldn't you add them?
83. Angelica says, wouldn't we add them together? Jessica answered 83. Stormy, what do you think?
Yeah, I think I'm Adam because it's not.
What's that?
Yes, I'm Adam. So.
You're adding them? Yeah. So 52 and 31 is 83. Yeah, we're using our angle addition postulate. All right. It says angle EH bisects angle IEF. So notice we have this huge obtuse angle IEF, correct? Or FEI,
Yeah.
the very big one on that, using those outside rays, and it's claiming or saying, it's giving that ray EH is bisecting that. So you're like, all right, what does bisect mean? Bisect, divide by what, Abby?
2.
2. Okay, so we put that in our heads. Now they're saying HEF, so go find HEF. H at about the 9 o'clock position, E, vertex, F up at about the 11 to 12 position.
The not so right angle.
It's not so right, that's correct. They're saying that is 57 degrees. And we want to know the measure of angle 5, which is HEI or IEH. And they're telling us EH is the bisector. What is the measure of angle 5?
I won't say it like that.
Well, what does bisect mean?
Oh, okay, so 57.
And so, no. All right, so let's back up and read this again. Super careful. EH is the bisector of IEF. The whole thing. The whole thing, right? It's the bisector of IEF. And they're telling us the measurement of HEF. So find HEF. H is at 9 o'clock. Back to the vertex E, back up to F. That one angle that's made up of two angles, isn't it? 3 and 4. That one angle is 57 degrees. And EH is bisecting the whole entire thing, IEF, and they want to know the measure of angle 5. You're thinking too hard. Hint, hint. HEF is 57. What is angle 5?
Something like 57.
They did, nope, they didn't say IEF is 57.
Oh, no.
33.
Nope, they didn't say IEF was 90 degrees. They said that it bisects. Bisect means divide in two. Are angles that are bisected congruent? If an angle is bisected, does it create two congruent angles?
Yeah. Well, not necessarily.
What does bisect mean?
But into two.
If I divide 50 in half, what do I get? Does
25.
25 equal 25?
Yeah.
Oh. If HEF is 57, what should HEI be?
57.
57.
Hey,
Oh,
because this one is bigger.
What?
That's why.
Don't go off of how it feels. Never, ever, ever go off by how it feels or looks. Drawings are always approximate. You have to go off of your givens, okay? So, they gave you that this angle here, okay, is being bisected by this angle, this ray. So you have to just go, okay, no matter what it looks like, this angle, and then angle HEF, that angle, those are going to be the same, no matter what it looks like, because it gave you that this is bisecting. So if it said this top angle is 57 degrees and this is your bisector, then you have to be like, okay, this one's 57 degrees also, based on the math, not on the drawing. Okay? All right? It's based on the givens. All right.
Just to come up with my own idea.
Yeah.
That one.
Yeah,
57.
I know. When you look at it, it's like, no, if I put a protractor on there, that wouldn't be right. We can't do that. They're saying if HEH is the bisector, and IEF of IEF and HEF is 57, what is the measure of angle 5? And you just have to go, it's 57. No matter what it looks like, they're saying if it was this, then it would be 57. I could draw you a crazy angly drawing that doesn't even come close. I could and say if this is this, and the bisector doesn't even look like it's bisecting, and you'd be like, but it doesn't look like it's bisecting. You can't argue what it looks like. You have to go off the givens, okay?
You'll never win an argument with geometry.
Right.
Ha,
Yeah.
ha.
You wouldn't even really need a drawing for that particular question. You could answer it without the drawing. If EH bisects angle IEF and the measure of HEF is 57, find the measure of angle 5. You could come pretty close to not even needing a drawing for that, just based on the bisector. You'd have to know what 5 is. But. All right, try it again. The measure of angle GEI equals 90 degrees. Even if it doesn't look like it, they're telling you that.
GEI.
If the measure of angle GEI, so G is at about 10 o'clock, E is their vertex, I is at about 7 o'clock. If the measure of angle GEI, are you with us, Jessica? Okay. The measure of angle GEI is 90 degrees, and the measure of angle 5 is 42 degrees. Find the measure of angle 4.
I just guessed 42.
It's what is it? Measure of angle. So they're saying GEI is 90 degrees, and angle 5 is 42 degrees. What is angle 4?
90.
Angle.
What do you got, Stormy?
What do you mean 90?
So GEI is 90. Find GEI. That angle is 90 degrees. It has a ray in between 4 and 5, EH. It's saying that angle, GEI is 90. Find angle 4, or angle 5, which is IEH, or HEI is angle 5. That is 42 degrees. And angle 4 is missing. We don't know what that is yet. And that's HEG or GEH.
Oh, we have to find it knowing that 5 is 40.
5 is 42.
Oh, 5 is 42, and then the whole angle is 90.
Correct.
Okay.
The whole angle is 90. 5 is 42. What is 4? 48. Yes, 48. And this is, again, you can't go off of what the drawing looks like, because angle 5 looks bigger than angle 4, doesn't it?
Yeah.
It does, but we can't do that. We have to go off what it tells us, the givens. It says if. That's 90 degrees, and if the measure of angle 5 is 42, then the measure of angle 4 would be 90 minus 42, because those two add up to the big one, correct?
Yep.
Angle 4 and angle 5 add up to GEI, or IEG. You follow me?
Mhm.
Okay, be
Yeah.
super careful. See how the math is really easy? The math is so easy. 90 minus 42, whatever, right? But you got to make sure, what are they asking me, and not get tripped up by what it quote-unquote looks like. Okay? All right. A little trickery there. That's good practice for you. All right. Turn the page to 135E. We're going to talk about adjacent angles and linear pairs, which we already kind of discussed, but let's make sure we get these down. You have a big, huge tactile in the middle of your page of two lines intersecting. Let's start at the top point, which is Y. Yeah? All right. And we go diagonally down through about the 4 to 5 o'clock position. There's no point through that particular, from Y. It goes through a vertex point. It goes through an intersection point that they label X right below it. And then you keep following it diagonally through about 5 o'clock. There's no point. There's just an arrowhead. So it would be identified as line YX, because they would use that intersection point as one of the points. Okay? Go take your hands off of that line and go over to about the 9 o'clock position and find point W. Okay? And then go through just above the 3 o'clock position, through X, and then through all the way to Z. And we have a line WZ. Okay?
Linear.
Yeah, those are both linear lines, aren't they? WZ is linear, and YX is linear.
Mm-hmm.
When you have two linear lines intersect, they intersect at exactly what? Two lines always intersect at exactly, nope,
Same point.
1 point. 1 point. They will never intersect anywhere else. So the point they are intersecting at is X, correct?
Yes.
Now, at point X, at vertex X, they've labeled 3 of the angles. One to the left is number 1.
1, 2, and 3.
Then we go clockwise to angle 2 and angle 3. Okay? So we have YXZ is angle 2, YXW is angle 1, And then angle 3 we can't name other than to say it's angle 3 because there's not a point, another point on y-x to name it. Okay? So be careful of that. Sometimes that's how they label the drawings, and that's how we have to read them. Okay, so we have two lines intersecting at point X. They've labeled 3 angles. Name a set of adjacent angles. 1 and 2 are adjacent, yes. What's another pair of adjacent angles?
3 and
3 and what?
2.
2, 3 and 2, yep. And then there's no point to label the WX. We'd have to put a point on YX, like, you know, we could put S or something and then name WXX. There's no point for that one, but if we went all the way around, we'd have another pair with the 3 or the 1. These are adjacent angles, but what other kind of angles are they?
Linear.
Linear. Excellent, Bryant. They're linear. So the definition of adjacent means they have to have what? 2 things to have adjacent angles. Common side and a common vertex. Yes, Stormy and Abby. Yep, common side and common vertex. Then the definition of a linear pair means what?
Common ray and, or I mean,
So they have
They have to be supplementary, right?
Yes, they have to be supplementary to be a linear pair. They have to be adjacent.
Mm-hmm.
And the non-common rays do what? Go in opposite directions. They form a line, right?
Yeah.
So they have to be on a line. The fancy mathy terms is the non-common rays are opposite rays. They form a line. Okay? They're linear. They're on a line. So 1 and 2 are linear. 2 and 3 are linear. 3 and, if we could label that next one, if we wanted to label it number 4 right underneath the X, 3 and 4 would be linear. 4 and 1 would be linear. What are 1 and 3 to each other, even though that's coming up, and you now know it? What are 1 and 3? Jessica?
Are they vertical?
They are vertical. What are 2, and if we labeled the one that says X, if we labeled that a 4, what are they? Vertical. Vertical does not mean they're straight up and down in geometry. What are vertical angles? What's the significance of vertical angles? Why are they so important? What is the measurement of angle 1 compared to no? What is the measurement of angle 1 compared to the measurement of angle 3? They're congruent. They're equal. Always, always, always vertical angles are congruent. They're equal. So if the measure of angle 1 was 40 degrees, what's the measure of angle 3? 40. If the measure of angle 1 is 40 degrees, what's the measure of angle 2? Nope.
No.
Oh, 1 is 40 and
1 is 40. What would
3
be?
is 50.
1 is 40, then 3 would be 40.
Yeah.
They're vertical. They're opposite each other, right? They're vertical angles. What is 2? If 1 is 40, if the measure of angle 1 is 40, what is the measure of angle 2?
For me. 1.
The measure of angle 1 is 40. What is 1 and 2 together?
3.
Not that. What is angle 1 and angle 2? What? Right. That's what Bryant said earlier what they were. What does a linear pair always form? 180. So if the measure of angle 1 is 40, what is the measure of angle 2?
180.
No.
No, the measure of angle 2
140.
140. Oh my gosh, I need an Advil. Oh Lord. That was painful.
I know.
180.
All right. 180 minus 40 would be 140.
That was kind of simple, right?
All right.
180 minus 40 equals 180.
Oh Lord. All right. Turn the page to F 135. We have a tactile in the middle of the page. We have
Interesting.
a line. Let's look at our line first. Let's start at about 2 o'clock, 1 o'clock, 2 o'clock at S, point S.
I'm tired.
I know, this is
What
the
is
last
that?
one.
That what?
And go follow S diagonally down through point U. Notice we have a line there, it looks like, doesn't it?
Was it going to say Stu again? No. It's going to say SVU.
Oh,
there's a vertex.
There is a vertex.
It's T.
It's T, all right.
So
And from T, we have a ray that goes up about through the 11 o'clock position through R. So that's a ray.
It's going to say true.
It is.
The
You
next
have a
one goes
true
to
angle.
B.
And then there's a ray going from T, going through about the 5 o'clock position through V.
Yeah.
Yeah, okay.
Yeah.
Notice that RTV is not a line.
No.
That is not a line.
No.
But STU looks like it's probably a line.
Stu.
Yes.
And we are told that. We're saying in the
thought it
figure
is a
at the
line.
right, TU and TS are opposite rays. When you hear opposite rays, you immediately get to say, aha, I have a line. Because you learned that in chapter 1 or 2, that opposite rays form a line. That was one of our definitions, right? So TS and TU are opposite rays, so we know we have a line. But they did not tell us that our TR and TV are opposite rays. Okay. We got a bunch of angles going on here. Do angle VTR and UTV form a linear pair? VTR and UTV form a linear pair.
Yeah.
What?
No.
Oh, because a little.
Oh, yeah, we got a big, huge obtuse angle. And we got an acute angle, but they don't. Is there a line anywhere on those two? Do their opposite rays? They're adjacent, but their opposite rays don't form a line, do they?
No.
They're excuse me. Their non-common sides are not opposite rays, so they do not form a line, correct?
No, they doesn't.
That is not a linear pair. They're adjacent. A big, huge one and a little one. They're adjacent because they have a common vertex T and a common ray, TV, right? But no, their non-common sides are TU and TR, and those do not form a line. All right, so that's... All right. Name two angles that are adjacent to angle VTU. So angle VTU, name an angle that's adjacent to angle VTU.
Jason, so UT.
UTR, yes. UTR is adjacent to VTU. Okay, and there's one more. VTU.
RTS.
No, RTS is not adjacent. VTS, Angelica, yeah, because their common vertex is T and their common side is VT, right? And then, Angelica, you also named, when you named VTS is adjacent to VTU, what also are those two angles?
Linear?
They're linear. That's right, Stormy. They're linear. Excellent. Good.
You don't have to do it.
You did. You answered the last question. All right, so tomorrow we'll finish up the review. 3, 5, 3, 6, 3, 7. Yep, we have plenty of time to do that. And then Thursday, happy Halloween. You can take a test. And then the end of the quarter.
At least we're getting candy.
And then candy.
Yeah, when we're doing tests.
Candy.
Yeah.
Candy when you're doing the test.
Yeah.
Oh, geez.
I'm going to need it.
Yeah.
I won't sleep all the time.
Candy will just make you even more sleepy.
All right, won't sleep yet.
All right, I'm going to stop the recording and publish this, and then I'll send it to everyone, okay?
Okay.
Have a good day.
Bye.
Saturday every time.
Wow. Hey, before we turn off this button.